In today's lecture, we study the current amplification factors. So, now in our last lecture, we have seen common base, common emitter, common collector configuration. Now, today we will see the common current amplification factor, which is the ratio of change in input current to the change in which is the ratio of change in output current to the change in input current. This is for the AC current amplification factor. Now coming to the DC current amplification factor, it is the ratio of output current to the input current. Now here, if I consider this as if this is a common base configuration, if it is a CB, now in a CB, base is a common terminal and emitter is the input terminal and collector is the output terminal. Now here the emitter current, in all the cases we are taking, we have already discussed this configuration with the NPN transistor. So here also I am considering this is a NPN transistor and IE current is leaving, so IB current is entering and IC current is also entering. Now here the current amplification factor is what? Output current divided by the input current and denoted by the alpha, and that is output current is what? IC, and what is the input current? IE. Now if you take the ratio, that is the current amplification factor for the AC. Now this is for the DC. Now similarly we need to calculate the current amplification factor in CE and also CC. Now coming to the CE configuration, now if I am taking this as a CE configuration, now in this emitter is the common terminal and base is the input terminal and collector is the output terminal. Now here IE is leaving, now this is the IE current and this is the IB current. IB is leaving means IB and IC both are entering currents. So IB and IC. Now in this current amplification factor, definition for all the configurations are same. So here we denote the current amplification factor as a beta. Now beta is equal to output current IC divided by input current IB. So IC by IB. Now similarly, if we calculate the, if we take the current amplification factor in a common collector, now if this is a common collector configuration, now here the common terminal is collector, input terminal is base and output terminal is emitter. And if you see the currents, here emitter current is leaving current and base current is entering current and IC is entering. Now here the current amplification factor is denoted by the gamma. Gamma is equal to output current IE divided by IB. Now these are the three factors, current amplification factors in the three different configurations. Now we have to derive the relation between alpha, beta, gamma. These three current amplification factor relations we have to derive. Now relation between alpha, beta and gamma. Now we need to derive this relation. Now already we have seen that alpha is equal to what? IC divided by IE and beta is equal to IC divided by IB and gamma is equal to IE divided by IB. And what is the total current expression? Total current expression IE is equal to IB plus IC. This we studied in the operation, transistor operation. We studied the total current. Emitter will emits the charge carriers that will enter into the base and it will be collected, remaining charge carriers are collected by the collector. So there the total current IA is equal to IB plus IC we studied. Now this equation, if we divide with the IC, then we get, now IE by IC is nothing but what? 1 divided by alpha and IB by IC is nothing but 1 divided by beta plus 1. Now from this expression, if you try to calculate beta in terms of alpha is equal to alpha by 1 minus alpha. Similarly, if you calculate the expression for the alpha, then alpha is equal to beta by 1 plus beta. Here alpha value is always less than 1. Why? Because now if you see beta divided by 1 plus beta means if you take this alpha value is always less than 1, and also if you see alpha, IC is the output current and IE is the input current. From this expression, IE is equal to IB plus IC, where IB is very, very small. So IC is almost is equal to IE we are considering. So here, this is a small amount of current. IC is very little amount of current is less than the IE. So thereby what? Alpha always we get the less than 1. So this is the current amplification factor in the common base. Similarly, beta value if you see, it is from 50 to 500 value. So now we need to calculate the relation between gamma and beta and later for this 3. Now from the same expression, again I am taking the total current IE is equal to IB plus IC. Now if I divide this expression with IE, if I am dividing this expression with IB, then total expression you divide with IB, then you will get now here IE by IB is equal to what? IE by IB is equal to gamma, and IB by IB is 1, IC by IB is equal to beta. Now with this what we got, gamma is equal to 1 plus beta. Now here what is the output current? Output current is IE and input current is IB. So here IC by IB, so almost beta and gamma values are same. So we can write it as the relation between alpha, beta, gamma is equal to, alpha is equal to, already we derived that, beta divided by 1 plus beta. Now where 1 plus beta is equal to what? Gamma. So alpha is equal to beta divided by gamma. This is the relation between alpha, beta and gamma. And CC, common collector configuration, generally practically we don't use. That's why, so mostly we try to design the common collector amplifier by using the common emitter configuration. That's why we use only beta. So this gamma factor, and if you see, almost gamma is equal to the beta. And we try to calculate the relation between now current relation between IC, IB and ICBO. Now what is this ICBO? When if this is a transistor and we are connecting reverse voltage to the junction 2, so here we are connecting the reverse voltage. So thereby what happens, here the depletion region forms and this depletion width is more, and when the input is opened at the time by this, now if I am taking this is a NPN, now here I connected the positive end. Now from this positive terminal, so charge, now IC current is flowing like this due to the electrons. Now at the time positive, because of this positive terminal, so minority charge carriers enters into this and the current will flow like this. This is called the ICBO. So this ICBO is the minority charge carry current. So in the collector, total current is equal to IC minus ICBO. So now here we need to derive the expression between IC, IB and ICBO. So for that, so now already we know that alpha is equal to what? Alpha is equal to IC by IE. But now here in the earlier when I derived the current amplification factor, there I neglected the leakage current. Now here if I consider the leakage current, then alpha is equal to IC minus ICBO divided by IE. Now here if I consider the leakage current, then I have to output current, total output current is equal to what? My majority charge carrier current plus minority charge carrier, and both the currents are in the opposite direction. That's why we got the minus sign over here. Now we know the total current IE is equal to IB plus IC. Now from this expression, from the expression 1, so from expression 1, alpha IE is equal to IC plus ICBO. Now here IC is equal to, what can we write? IC is equal to, sorry, here it is minus. So IC is equal to, what can we write? Alpha IE plus IC BO. Now IA is equal to, if I substitute this equation, substitute equation 2 in, if I take this as a equation 3, in equation 3, then what you will get? Now IC is equal to, I can write alpha into IB plus IC plus IC BO. Now all IC terms write together and take the IC out, then it look like this. So IC, now minus alpha IC I am taking to that side, minus alpha IC is equal to alpha IB minus, sorry, plus IC BO. So here IC I am taking, if I am taking IC out, 1 minus alpha is equal to alpha IB plus IC BO. Now if I send the 1 minus alpha to this side, then alpha by 1 minus alpha IB plus IC BO by 1 minus alpha. Now there alpha by 1 minus alpha, we can write it as IC is equal to beta IB, and 1 by 1 minus alpha is equal to 1 plus beta IC BO. This is the total collector current expression in terms of IB and beta IC BO. So this is the relation between IC, IB and IC BO. So with this current relations, we got the current relations. Thank you.